Hey guys, so this is the notes for, as you can see up here, 2.4 notes, key features of functions, and we did already talk a little bit about key features of functions. The features we're going to have to point out are the x-intercept and the y-intercept, which you can see are defined here. The x-intercept is where the graph crosses the x-axis, and we could identify those points as coordinate pairs. And down here you have your y-intercept, the place where the graph crosses the y-axis. So this graph has two x-intercepts, and they are, if you look at those green points, they are -2, 0 and 4, 0. So there's that. And then the y-intercept is, of course, like I said, where it's the point where the graph crosses the y-axis, and we can identify it as an ordered pair. In this case, it's 0, -8, and this will be a recurring theme. X-intercepts have 0 as the second number. The output is 0 for the x-intercept. That is the y-coordinate. The y-coordinate is 0 for the x-intercept, and the y-intercept is the opposite. It has 0 as the value for the input, aka the y value. So y-intercept 0 is the first number, and x-intercept 0 is the second number. So moving right along through these notes, here I had already answered this. It says, why do you think there can only be one y-intercept for any function? Well, that's because having only one y-intercept means that each input has one unique output. If we end up with another point anywhere along the y-axis, then we don't have a function, because again, remember, every time an input goes into a function, it has to give the same output. So that would be a reason why we would never have two y-intercepts. So moving right along, and in this one, I already answered this one also, but let me it's still finding the intercepts, but first we have to graph these points. So graphing these points, remember the first number for graphing a point is always movement to the left or the right, unless it's 0, and then I don't go left or right at all if it's 0. But either way, the first number tells me to go either left or right. These are all negative, so these are all leftward movements. If it would have been positive, I would go right. And then the second number tells me to either go up or down. So if it's positive, I go up, and if it's negative, I go down. If it's 0, then I don't go up or down. So first point, -4, 3, that's left 4, up 3, so that's this point right here. Second point, -3, 0, that's left 3 and then 0. And then the third point, -2, -1, that's left 2, down 1. The fourth point, -1, 0, is left 1 and stay there. And then the last point, 0, 3, is, well, stay at 0 and then go up 3. So those are all my points, all those blue dots. And then this is technically supposed to be a curved graph, a curved shape, not like a hard V. So did my best to draw that in. And anyhow, the x and y intercepts, I've identified them as the x-intercept here is left 3, so it's -3, 0, and then here left 1, so -1, 0, and then the y-intercept is up here, it's at 0, 3, which I've identified here. So there's that. This next one is pretty much the same, and I'll go ahead and graph these points now. -4, 6, that's going to be, let's see if I can zoom out a little so I can see it. So -4, 6, that's left 4 and then up 6. -3, 0, that's left 3 and stay there. -2, -4, that's left 2, down 4. -1, -6, left 1, down 6. And then 0, -6, that's stay at 0 and go down 6. 1, -4 is right 1, down 4. 2, 0 is right 2 and stay there. And then 3, 6 is right 3, up 6. And this is another one of those curved graphs. So So I'm going to try to draw this in, but it's not too easy to use this trackpad for drawing. Let's see here. Yeah, that's not supposed to be so squiggly there, but either way, it's this U-shaped curve again. I guess you could even say it's V-shaped, but either way, a few things you guys will learn this year is that this type of graph that makes a U shape, and it could actually be an upside down. You can think of it maybe as a smile and a frown, actually. It always is associated with the equation with an x squared. So there's my graph, and you can see the two x-intercepts. There they are. You really don't need to graph it to see the x-intercepts, though, because the x-intercepts are always where the second number is 0. So I already know the x-intercept is -3, 0 here, and the other x-intercept is 2, 0 without even graphing. And I know the y-intercept is 0, -6, because anywhere x is 0, you have your y-intercept. So I already know these things without graphing. However, you still need to be able to graph, so you can also see those intercepts better when you graph. Again, x-intercepts here where it crosses the x-axis, and your y-intercept is down here at 0, down here at 0, -6. I didn't make the graph so perfect, actually. I should have done a better job, but basically the graph should have dipped down a little bit lower here. Let me see if I can fix that. Yeah, I'm gonna fix it. So like I said, the graph should have kept going here, kind of dipped down just a little below these points, let's say, and then kind of go back up. Anyhow, your y-intercept is here at 0, -6, so your x-intercept, there's two of them, remember, it's -3, 0 and 2, 0. Just gonna find those points. And then your y-intercept was 0, -6. So there's that one. So graphing and finding the intercepts, this one we did do in class together, but I'll just quickly brief you. Remember, we had our function and we had our inputs, so for each input we had to calculate the output, and Desmos does that for us. We just have to kind of punch in the formula. So anyhow, right here we could use the 2x plus 5 to calculate with our input. So we plug our input into the function, and anyhow, we got all these outputs. Again, I'll show you that in one of the next ones. So either way, we had to do or calculate our outputs for this one, and then we graphed them. -2, 1, -2 up 1, left 2 up 1, -1, 3, left 1 up 3, 0, 5, that's stay at 0, go up 5, 1, 7 is right 1 up 7, and then 2, 9 is right 2 up 9. So those blue points are all the points, and then I just use the line tool to draw the line in, and you could see the y-intercept really clearly. And here, if you extend the line, you can see the x-intercept is here, and you got to kind of estimate. It looks like about -2.5, so that's what I estimated here. X-intercept is -2.50, y-intercept is 0.5. So I think that one's good. I'm going to go to the next one. So I started plugging in on this one, and so I'm going to go ahead and continue using the function x squared minus 5x plus 4. In this case, plug in a 3, so 3 squared minus 5 times 3 plus 4, and then just press enter and it calculates it for you. Next, plug in a 4, so 4 squared minus 5 times 4. By the way, the squared, you can either get it from here, or if you just press shift 6, that up arrow makes the exponent. So again, you can get the exponent from the keyboard on Desmos, or you can press shift 6 on your keyboard, and the up arrow on 6 gives you the exponent. So either way, there's that one. That one's 0, and then here 5 squared minus 5 times 5. plus 4. And the answer is 4. So another thing you'll start to notice about these parabolas is, again, it has an x squared, so it's going to be that curved shape. Another thing you'll notice about that is from the middle, the left and right side are a mirror image of each other. So from the middle, which is called the vertex, the left and right side start to match. So you'd see that here with the -2s, the 0s, and the 4s. That's because the left and right side match from the middle if you move left to right in a parabola. So I already graphed 0, 4, and 1, 0, and 2, -2. And now I have 3, -2, right 3, down 2. And then I have 4, 0, so right 4 and leave it there. And then 5, 4, right 5, up 4. And again, this is one of those parabolic shapes, a parabola. It's like a rainbow or a U shape. And I'm just going to try to draw that in. Remember, it's supposed to be a smooth curve. Not that easy to do with this trackpad, but either way, just kind of let that be. I can still see my x-intercepts. My x-intercepts are here at 1, 0, and 4, 0, and my y-intercept is at 0, 4, and all that information I can kind of tell from the points before I even go there. So, again, x-intercepts, 1, 0, 4, 0. Oops, let me fix that. Okay, there's your x-intercepts, 1, 0, and 4, 0. The y-intercept on this one is 0 and 4, 0, 4. Okay. So again, those points come from here, right? Your y-intercept where it crosses the y-axis, 0, 4. And then the two places it crosses your x-axis are your x-intercepts, 1, 0, and 4, 0. This one is the same, so I'm gonna plug in. I'm gonna finish plugging in on this one. That would be 1 squared minus 5 times 1. Minus 6. So you could just keep doing that to plug these numbers in. So I went ahead and plugged a couple more in. Either way, you can use this down here to do that also. So. Just press enter at the end, right? What you're noticing is, again, a mirror image. On the left and right side, you'll have matching heights. The height of the graph will match on the left and right of the center or the vertex. Next, I have 5 squared minus 5 times 5 minus 6. Whoops, don't need that equal sign, just need to press enter. And then the last one, 6 squared minus 5 times 6 minus 6. And there we go, 8. So you see all the numbers there. Let's go ahead and graph these. So -2, 8 is my first point, left 2, up 8. Again, that's -2, 8, left 2, up 8, and then -1, 0, left 1, stay there, 0, -6, so stay at 0, go down 6, 1, -10, so right 1, down 10, and then, let's see, oh, this graph doesn't go all the way down, guys. So I guess we'll skip those -12s, and then let's go to 4, -10, 4 and -10, and then 5, -6, right 5, down 6, and then 6, 0, and 7, 8, 7, right, up 8.